Good afternoon. I am Mr. Ish. Thank you for joining me for this geometry proof challenge video. We're looking here at a specific proof, or you can say verification procedure, which is frequently not performed. Geometry students normally end up missing out on this very important exercise. We have in this video to prove the following: that the sum of the external angles for any polygon always equals 360 degrees. What does that mean? External angles. Let's look at a triangle. When we're looking specifically at this angle, we know it's an internal angle because it's internally placed. If you were to extend any of these lines outward, whether it was this one or this one, now you've generated an external angle, and that external angle is this. If you were to generate external angles for all of these vertices of this triangle, you've generated three external angles. One is this, one is that, one is that. If you were to add up all of these three external angles for this triangle, it will always equal 360 degrees. Likewise, if you did the same for another shape, be it a 4-sided, 5-sided, 6-sided, 7-sided, no matter how many sided, external angles will always equal, for any shape, these external angles will always equal a 360 degrees sum. We have to prove that to be the case. Why are all of these external angles for any given polygon always equal to 360? And that right there makes for an excellent challenge proof video. What are we given in terms of what we can use to do this? How about this? We're given the following formula: n minus 2 times 180 always gives you the sum of the internal angles of a polygon. You probably remember this formula from your geometry class, or maybe algebra class, or even maybe the SAT or the ACT exam. The sum of the internal angles for any polygon is always given by that formula, n minus 2 times 180. That's one item we're given. The other item we're given is this n. What does n mean? It refers to number of sides. And last item we're given is basically the definition of a supplementary angle. We know what a supplementary angle is. If you knew that, you could utilize that into your proof procedure. A supplementary angle are any number of angles, normally two, which add up to 180 degrees. Two angles or any number of angles which by their cumulative sum are equal to 180 degrees or a straight line. Given these three items, let's do this proof. The proof starts with this. We'll just put a little word here, start. It starts with that formula I've given you, n minus 2 times 180. If you're looking at a polygon with n number of sides, and we have to prove that that specific polygon has external angles, the summation of those external angles equal 360. If this equals the sum of the internal angles for a given polygon, you were to divide this by n, the number of sides you are given, you are now equaling what? The measure of a single internal angle. If you have this formula, n minus 2 times 180, you divide it by n, now you're determining the measure of a single internal angle. If you take this specific measure right over here, all of this, and you minus it from 180 degrees, let's do that. N minus 2 times 180 over n, all of this. Now what are you measuring? You're measuring now the measure of a single external angle. That's what you're measuring now. Hypothetically, if supposedly we have a shape like this, here's my internal angle. If I know this, I measure this and let it be a, and I measure it from 180, then the external angle is 180 minus a. This is exactly what I'm doing here. If this represents a, I'm doing 180 minus a. That'll give me this measure of this external angle. So that's step number 2. This proof procedure is slightly out of the ordinary. It's not in the typical way. I've done it in this way specifically so it's easy to remember and easy to comprehend. Now that we have a measure of a single external angle, all we have to do, if you were to multiply this measure of a single external angle by n sides, all of this, if you were to take this measure of external angle, a single external angle, and you multiply by the number of sides, you know n equals number of sides, it will equal 360 degrees. And by doing this computation right here, you'll end up proving it. Let's verbalize everything. We start with here the measure which gives a indication of the sum of the internal angles of that polygon. You divide that by the total number of sides, you end up with a measure of a single internal angle. We know each internal angle, by virtue of a supplementary angle property, is combined with a external angle, because that internal angle and the external angle are supplementary in the sense that they form a straight line. You can do 180 minus that internal angle measure, and it'll give you a measure of a single external angle. If you take this measure of a single external angle, you multiply by the number of sides, you should get 360, because that's what we're saying, that the measure of all the external angles for a polygon, you add them up, you summate them, you'll always get 360 degrees, and that right there should take us to our last step. Do a common denominator right over here. You'll have n sitting outside, you'll have 180n. Open this up, you'll have 180n minus 360, which hits with this minus, becomes a plus 360, all over n is equal to 360 degrees. This n and this n will cancel out. This 180n and minus 180n will cancel out. You'll end up getting 360 degrees is equal to 360 degrees. And you've ended up proving in this specific challenge that the measure of all the external angles for any polygon is always equal to 360 degrees. You could put in here n value of any sided polygon and it will always give you that. And let's say n is equal to 7. Looking at this formula right over here, measure of a single external angle, you'll do 7 minus 2 times 180. You'll get 900 divided by 7. You minus that from 180. Here I'm getting each external angle for a 7-sided polygon is 51.428 degrees. I put this 51.428 and I multiply it by the number of sides. I multiply that by 7 and I'll get exactly what I want, times 7, 360 degrees. So this right here is a proof completed. You start, and I'm going to verbalize again. You start here with the total sum of the internal angles for any polygon utilizing the formula that's given. You divide that by number n. It gives you the measure of each single internal angle, which happens to be in a supplementary angle relationship with an external angle. You do 180 minus this, it gives you a measure of a single external angle. You take the single measure of external angle, you multiply by the number of sides you have, algebraically solve all of this, and you get 360 equals 360, and the proof is done. With that, I thank you for watching this video, and for my other videos, leave any comments or concerns you have and I'll respond to them. Have a nice day. Thank you for watching.